Hi, Assalamualaikum. My name is Hariz bin Huszian, metric number DE200003, and I will be presenting the first slide, which is methodology. Okay, what is methodology? Research methodology is a method or a step collecting and analyzing information or data. It is used as an evidence to support a conducted research. Okay, in this project, one of the method was project simulation. Okay, project simulation is when we create and assemble and test the project circuit, which is RLC circuit, using software such as Multisim and MATLAB Simulink. The next method that we use in this project is manual calculation. For question 1, we must do manual calculation to find the values that were asked in the project questions. Then the value for the manual calculations were used to make simulation of critically damped, overdamped and other damped response circuit. Okay, for the question 2, it is required for us to prove the simulation done in question 2A. So the manual calculation was made either using mesh, nodal or superposition analysis.
Okay, Assalamualaikum. My name is Muhammad Nabil FARHAN bin SHARIFFUDIN. My metric number is CE200116. Today I will present you the project for electrical circuit 2 for the question 1A and 1. For the question 1A, figure 3.1 shows an RLC circuit. Assume that the current source IS is a 4 amp. IS current circuit is 4 ampere is applied to the circuit. The inductor has initial current is 2 amp. The initial current for the inductor is 2 amp and the initial capacitor voltage is 30 volt. Design your circuit to obtain overdamped, critically damped and underdamped response. Let the radial frequency with 300 radians to sustain the component value design. Okay, I will show you my simulation for this question 1A. For the overdamped, we will use V-stepping source and we use inductor for H, and we use inductor 1 microfarad and we use resistor with 500 ohms, and we will connect to the oscilloscope for the channel A, and we will run for the 2 amp, and for the graph overdamped is just like this. We will stop and we will show there is a little damp in this graph, so this is the simulation for overdamped. Okay, for the critical damp, same component but the different from the overdamped is we use a resistor 1 kilo ohm, and we use also this step source, and we use inductor for H, and we use capacitor 1 microfarad, and we also use oscilloscope to make the connection. Okay, we run the simulation and get for the graph for the critical damp that's like this. Wait, we so a little bit higher than for the overdamped, as we can see. Alright, this is for the critical damp. For the underdamped, we use the step source, we use inductor for H, we use capacitor 1 microfarad, and the difference from the critical and overdamped is a resistor. We use the resistor 2 kilo ohm, and also we use oscilloscope to show the graph for the underdamped. Okay, we run. Okay, stop. We get, yeah, that's like this. We saw the graph for the underdamped a little bit down from, yeah, we saw a little bit down from the graph. It's straight. This is for overdamped, and this is for critical damp, and this is for the underdamped, as you can see. Okay, thank you.
Assalamualaikum and hello. My name is FATIN JEFRI. today I'm going to present about our project. I will explain the answer for question 1C and 1D. For the 1C, the question asks to simulate the circuit design in 1A and plot all the response for VC and IL for 3 greater or same to 0 second on a single graph. So I use Simulink in MATLAB to simulate the circuit and to answer this question. I made 3 different graphs which is for all the response for VC, IL and a combination between VC and IL. The graph for VC shown the difference between critically damped, overdamped, underdamped response. The green line is for critically damped, the pink line is for underdamped, meanwhile the blue line is for underdamped. Next, the graph for IL. You can see the different line color in the graph here. The light green is for critically damped, the light blue line is for overdamped, meanwhile the purple line is for the underdamped. Lastly, you can see the response graph for the combination between VC and IL. The light green line is for critically damped and pink line is for overdamped. Meanwhile, the blue line is for underdamped for the VC, and the maroon line is for critically damped, the purple line is for underdamped, and while the orange line is for underdamped for the IL. That's all for question C. Now, for the question 1D, the question asks to analyze the response from part 1C that will give the shortest time on reaching 80% of the final value of VC and give comment and conclusion. So, the answer for the question 1D is the response from part 1C that will give the shortest time on reaching 80% of the final value of VC is critically damped response. It is because the resistor that used in the circuit is the smallest between the 3 circuits, which is 1 kilo ohm. So the voltage can reach the final value more faster and shortest time to reach 80% of the final value. The conclusion is resistors are used to reduce current flow at just in level to divide voltage, bias active element, and terminate transmission line, among other use. That's why the circuit that use 1 kilo ohm has the shortest time on reaching 80% for the final value. Thank you. That's all from me.
Okay, for question 2A, we are required to do a simulation of an RLC circuit that have been given in the questions. Okay, to make the simulation of it, we need to use a simulation program which we opted to use multisim. Okay, before we can create the simulation, we need to create the circuit itself and input the value as by given by the question. After that, we need to put the probe onto the circuit so that we can measure the I1, I2 and Vout which is asked in the questions. As you can see, this is the result of the simulation. It shows the real and imaginary value for the simulation of I1, I2 and Vout. Thank you. Okay, now we need to prove the simulation with manual calculation. As you can see from the picture beside me, they have given the VS1 and VS2 and also the omega, which is 100. And then to find the frequency, we need to use the formula of 2 pi f, and then we can get the frequency which is 15.92, and then we convert the VS1 and VS2 to phasor form, and after that we convert it again to a complex form. Okay, as you can see, we use the mesh calculation, and from that we have 3 equation that we can get from the value. Okay, after that from the third equation we can find the fourth equation, and after we got the fourth equation, we need to substitute the fourth equation to the second equation. Now for the next step is for the equation 1 and 5 to put it in a matrix to find delta. Delta is AC minus BD, and then we get negative 1600 plus J 2200, and then delta 2 is negative 5273.846 and minus J 2510.769, and then to find I2 we can use delta 2 over delta, and we got 0.394 plus J2.11 ampere, and then we substitute I2 in I4, and then we get I3 is 0.542 plus J1.871, and then after that we use the substitute I2 in I1 to get I1, which is 2.068 plus J3.489. So to summarize, I1 will be I1, the I for the I1 loop 1 is I1 plus I1 minus I2, which is 2.068 plus J3.489 minus 0.394 minus J2.11, and then the value will be 2.68 cos 100t 39 degree ampere. And then for the second one, I2 is 0.281 cos 100t 122 degree ampere. And the last one is V out 56.2 cos 56.2 cos 100t plus 32 volt. And as you can see from the picture beside me, that is the comparison between the simulation and calculation. Okay, now for the question 2, we need to plot the steady state current and voltage response of I1, I2 and voltage out, V out. And so we use the simulation before and we plot the graph into one graph, which consists of the I1, I2 and the V out. So for the first graph, as you can see, it is a combination of the three results with 0.01 time stop for the graph. And the second one is the graph of a combination of three results with 1 second time stop. And you can see that red is the I1, green is the I2 and the blue one is the VO.